Hello, Algebra 2 students. This is Mr. Kingsbury, and today I'm going to guide you through the characteristics and transformations of exponential and logarithmic functions. So what are these things, exponential and logarithmic functions? Well, let's start with the exponential ones. You actually saw that back in Algebra 1 a little bit. It is a function where you have some number, we'll call it b, and you're going to raise it to an unknown exponent. In fact, the exponent is the thing that's going to change. And you're going to graph all of those things. It's going to be amazing. What happens is, as the exponent gets larger and larger and larger, your graph is going to get bigger and bigger and bigger real quick. As it gets smaller, what happens is your value becomes just a smaller and smaller decimal. So it gets closer and closer to the x-axis, or actually, as we'll see in a little bit, a horizontal asymptote. Right? It may not necessarily be the x-axis, although for the parent function, which is what this is, the horizontal asymptote is in fact the x-axis, which is great. And then we have our transformation here. Keep this in mind. There's going to be a number. You're going to ignore this number here. A is in front of it, and then C is in the exponent, and then D is on the end as always. I'll walk you through a few. So exponential functions, basically they're based off of the exponent notation, right? When you have something that's being multiplied by itself a bunch of times, you can write it very quickly by just putting that number and then writing a little small number to the upper right of the original number. So the number that's being multiplied by itself a bunch of times, that's called the base. Obviously, this is the exponent, which is, we know that, or the power, and then the thing that it's equal to is called the argument. We'll talk more about that later. You don't need to worry about it right now. So first of all, we need to go through what the characteristics are, and then we'll talk about transformations. Now, let's jump to logarithms, and logarithms were developed to be the inverse of exponents, because there were times that they couldn't solve, or problems couldn't be solved, without some kind of help, right? So the logarithm was invented or established, I guess, to be the inverse of the exponential. Essentially, with an exponential function, you take some number, you raise it to a power, and you get another number. So what you're trying to find is, if I raise this number to the third power, what do I get? I don't know. I guess if you use square roots, you could say, hey, I have some number, I don't know what it is. I'm raising it to the fifth power, and I get this. You could take square roots, no big deal. But when it came to trying to figure out what the exponent was, when you had a problem that was like, hey, I've got some number, and I'm raising it, I've got 5, and I'm raising it to some exponent, I don't know what, and it gives me this other number, well, that was difficult. So logarithms were formed to figure that exact thing out. So what you have going on here is that same base, only this time you're taking the log is short for logarithm, of the actual, the argument, if you will, the number that it's equal to, and what it spits out is the exponent. So we'll get to that. Right now we're not worried about that for this lesson. Here is our transformation form. A will be in front of the word log. Again, there will be this little base number ignored entirely. C will be inside the parentheses, and D will be on the end. Okay, no big deal. Couple things that you should know. I'll just bring them down here. So I mentioned this word base, right? That's the number you are raising to an exponent or multiplying by itself a whole bunch of times. There are two special bases. If we do not mention what the base is, if it's not written out expressly, assume it is 10. And then there's another one that's very, very unique. It is called E. E is the natural log, or it's called the natural constant. I'm not sure why it's called that, because if you look at it, it's a decimal, 2.71 blah, 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 forever. But apparently it appears in nature all over the place. They use it in finance a lot, so it's important. And for that one, when we have a logarithm that has a base of E, we don't write it as log, we write it as ln, that's natural log. It's actually words in another language where the adjective comes second. It's like logarithm natural or something, so it's ln. But that's what it means, is natural log. Really, for us, it'll just be the difference of pushing a different button. Alrighty, so let's jump into the characteristics then. You know things like x-intercept and y-intercept. I'm not worried about that. And you're getting pretty good at domain and range. I'm going to tell you that for all exponential functions, the domain is always all real numbers. For logarithmic functions, the range is always all real numbers. And then you'll have to figure out the other one. It'll always start at the asymptote and either go to the right or the left, or in the case of exponents, up or down. And I'll show you how to write that here in just a second. But there will always be one asymptote. If there's a horizontal asymptote, there's not a vertical one, and vice versa. And do not worry, all of the questions that we ask you characteristics about, you'll get a graph for. So let's do this. And I thought about doing all of these, but I'm going to do numbers 1, 2, 3, and 6. So let's start with number 1 here. It's an exponential function. I know because I'm looking here and I've got 2 raised to the x minus 4 plus 1 power. So exponential function. And as I mentioned, the domain will be all real numbers. The domain for all exponentials is all real numbers. Very important. And you can tell that because we've got an arrow pointing to the left and an arrow pointing to the upper right, but it is still going to the right. The range is going to start here at the horizontal asymptote, which crosses the y-axis at 1. So I'm going to start with 1. That will be less than or equal to y. And then you'll note that the graph, if I go to the right, it just kind of peters out. It's going to get closer and closer to 1. But if I go to the, I'm sorry, that's to the left. If you go to the right, it's going up with an arrow. It means it's going towards infinity, which is awesome. I've already mentioned that this is a horizontal asymptote. It crosses the y-axis, so we'll use y equals, and it crosses at 1. So y equals 1. The x-intercept, well, since this does not ever cross the x-axis, there's going to be none. And the y-intercept we actually wrote out for you right here because it was a yucky one. So we'll go 0, 1.063. No big deal. See, easy peasy lemon squeezy. I'm going to zoom this out just a little so you guys can see more of what is going on here. Number 2, this one's definitely a logarithm. I know because it has the word log in it. So I'm going to circle logarithm or logarithmic. And I remember that all logarithmic functions have a range of all real numbers, which you can see this arrow is pointing down and this arrow is going up and to the right. So it is going up. So it's going to be all real numbers. The domain is going to start here at the vertical asymptote, which happens to be the y-axis, which is 0. So we'll go 0 is less than or equal to x, and then it goes to the right. That's an arrow. It doesn't stop. It's going to go on forever, which means it's less than infinity. As I just mentioned, we have a vertical asymptote. All logarithms have a vertical asymptote. All exponentials have a horizontal one. So it will be a vertical asymptote, you can see from the picture, and it goes through the x-axis, which means we're going to use x equals, and it happens to go through right on the y-axis, which is x equals 0. The x-intercept is right here. That's a big number, 177,828, 0. And since the vertical asymptote is the y-axis, this will never cross the y-axis, which means there is no y-intercept. So far, so good. Number 3. Again, I look at the equation, and that definitely has a log in it. So I'm going to say that this is a logarithm. And again, logarithms have a range of all real numbers. Again, the domain is going to start at the vertical asymptote, which in this case goes through -3. 1, 2, 3. So it will start at -3, less than or equal to x, then less than infinity. That tends to be the case for logarithms and exponentials. One side will always go to either infinity or negative infinity every time. I mentioned we have a vertical asymptote right here, so that will be x equals, and it goes through -3, so x equals -3. The x-intercept is right here at -2, 0. The y-intercept is here. We've written it in because it is a decimal. 0, 0.528. Boom shakalaka. Pretty straightforward, huh? I'm just going to do one more off of here. Do number 6. I can get up there for you. Number 6 is an exponential. Note it has a base of e. It's not really all that important to us right now, but I wanted to do one with e just so you could see it and start to get familiar with it. So this is exponential. Basically, I know that because the word log is not in here, but it definitely curves up. The domain of all exponentials is all real numbers. The range will start down here at the horizontal asymptote, which is at -11. It will be less than or equal to y, and then less than infinity, because if you go up, notice the arrow pointing up forever. And yes, I did mention this is a horizontal asymptote. It crosses the y-axis, so I'm going to use y equals, and it crosses at -11, so I'm going to do y equals -11. The x-intercept is here. We had to write it in for you because it's a gross decimal. So we got 2.398, 0. And then the y-intercept is right here at -10. That'll be 0, -10. And that's characteristics. At this point, you guys should be pretty good at these. We've practiced them a lot. And I'm really thinking you're getting the hang of it. On the other side, we have our transformations. And I know y'all are getting good at this, so I'm not going to spend tons of time on it. Up here is a review of what each thing covers. Remember that the A value has 2 pieces. The negative means a reflection. The value means it's either a stretch or a compression vertically. Remember that C moves the thing left and right, and D moves the thing up and down. So I'm actually going to change this so negative C means it moves left, and positive C means it moves right. Please feel free to do that yourself. Once again, I don't want to do all of these, especially since you guys are getting so good at this. But we do need to do a few. So let's take a look here. We're going to identify A, C, and D. So my A will be in front. That's 2/7. My C will be in the exponent. My C looks like it's 3, but remember we always change the sign. So we're going to go with -3. And then my D would be added on to the end here. Like see on number 1, I have a +7. That would be my D value. I don't have that here. I have nothing, right? So I don't need to worry about D. I'm going to cross it off. And then I just need to interpret these things. So 2/7, an A value of 2/7 would be a vertical compression by 2/7. And a C value of -3 would be left by 3, or left 3. And there you go. Let's do a couple more. Number 3, let's identify A, C, and D. Looks like my A is just a negative. That would be out in front here. My C would be here up in the exponent. All I see is an X. I don't see anything being added or subtracted to it or from it. So I don't have a C. Looks like C is 0, and I don't have to worry about it. And then we've got +9 on the end there. That's my D value. So let's interpret these. The negative means there's a vertical reflection. Or if you want a reflection over the x-axis, that's fine. And then a D value of 9 means we're going up 9. That's not too bad, huh? So far, so good. Just do a couple more and we'll call it a day. Number 4, let's find A, C, and D. My A is out in front of the, this is a logarithm, so my A is in front of the word log, that would be 4/3. C would be inside the parentheses. All I see is an X inside the parentheses. I would need something being added to it or taken from it. I don't have that, so there is no C. And then on the end here, we got -5. That's my D value. So let's interpret this. 4/3, an A value of 4/3 would be, I know many of you are thinking that it is a compression because what you see is fraction. But please remember, this fraction is larger than 1. This is actually 1.33333. That's bigger than 1. And if your A value is bigger than 1, that makes it a vertical stretch by 4/3. Please make sure that you write that all the way out. And a D value of -5 means the thing is going down 5. Then lastly, we've got number 6. Here we go. Let's identify our A, our C, and our D. A will be -3. C is inside the parentheses here. It looks like it's 5, but remember we always change the sign, so it's actually -5. And I don't see a D on the end there, so we don't need to worry about D. Now let's interpret this. The negative part of -3 means there's a vertical reflection. The 3 part of -3 means there's a vertical stretch by 3. Remember, those two are interpreted separately. And then a C value of -5 means we're going left 5 units. And there you go. That's day 1. Please bring any questions that you have to class. It's been fun. I'll see you there. Ta-ta.